The last video you watched was on calculating means and variances for discrete random variables. It'll often be the case that we want to be able to combine random variables and talk about mean and variance for the combination of those. Combinations of test scores, combinations of bowling scores, combinations of readings off two different machines, and talk about the means and the standard deviations and variances for those. And there are a few rules that apply. The symbolism's a bit challenging, so we'll try and show the symbolism and then walk through some examples. A reminder, you should have just seen this. We have a formula for mean here of a discrete random variable, which we're going to talk about first. It's the sum of every outcome times its probability. And we also have a formula for variance, which is the sum of every outcome times the mean of the random variable squared times the probability for that particular outcome. And when we take the square root of that, we're given the standard deviation. Now, these are the rules, and it's a bit nasty looking, and we're going to come back and talk about these one at a time. But listen to this. This is the basic idea. Means. If you have two random variables and you're interested in the mean of the combination, you can add means. It's as simple as that. You can subtract means. It's as simple as that. And that's what this formula in the upper right is saying. Variances. You can add variances. If you're interested in the variance for the sum of two random variables, you can add variances. It turns out that the variance for the difference in two random variables is also the sum of variances. Noise sort of piles on noise. You can think of variance and variability as noise in the data. It doesn't really matter whether you're adding or subtracting. Noise piles on noise, so we add variances. What you don't see here is adding or subtracting standard deviations. You cannot add standard deviations. You can only add variances. So we'll come back to, well then how do I get a standard deviation if I'm putting two random variables together? Let's talk about means and a couple of quick simple examples here. The symbolism on the right says the mean of some random variable x, if it's adjusted by multiplying by b and adding a, is equal to what you see on the right side of the equal sign. Let's take this as an example. Let's say I have test scores. And for whatever screwy reason, I've decided to do this. I'm going to double those test scores, and I'm going to add 10 to every score. Because I've decided that's what I want the scores to look like when I'm done. Well, before I did this, the mean for my test scores was, let's say, 40. Using the symbolism above, here's what I've done. I've taken that original mean, and I've added 10 and doubled the original test score. So we have mu sub 10 plus 2x. What's the new mean? Well, it's that number I added plus the doubling of the original test score. Well, what does that look like? That's 10 plus 2 times 40, which is 90. And that should make some intuitive sense. If the original test mean was 40, and I've decided to double all the tests and add 10, it makes sense that the new mean would be 90. And that's how the symbolism is meant to read. On the right, it's actually simpler. It says the mean of the sum of two random variables is the sum of the means. I'm part of a bowling team. How about that? Let's go with bowling. And I bowl with this guy named Spencer. And I'm interested in the average bowling score for the team of Jeff plus Spencer. Well, it turns out that's equal to my mean plus Spencer's mean. Well, I'm not a very good bowler. My average bowling score, despite growing up in Wisconsin, is 120. Spencer's a little better. He's 150. So when we bowl as a team, Jeff and Spencer, our mean is the sum of our individual means, or 270. I could also talk about the average difference in our bowling scores when I subtract Spencer's from mine, and that would be as easy as 120 minus 150, or negative 30. So you can add and subtract means. Okay, variance is a bit more challenging here, and we'll come back and go through these by example. What this says here is you can add variances and you can add variances. It doesn't matter if you're adding or subtracting random variables, you still add variances to get the variance of the combination. The first part here says if x is a random variable and a and b are fixed numbers, then we adjust the variance as shown on the right side of the equal sign, and I'll do that by example. These formulas only work, here's a multiple choice question, they only work if x and y come from independent random samples. So you might be asked these questions, is it okay to call these independent scenarios? Would I be okay adding variances here? Rainfall on November 6th of this year, November 6th the following year, are those independent? Probably. Amount of rainfall today, amount of rainfall tomorrow on consecutive days, are those events independent? Probably not. And you can read through the rest of these. If you're presented with the question of finding a combined mean and combined variance or combined standard deviation for two random variables, you have to decide if the two events you're given are independent or not before you combine variances. Let's talk about the rules for variances here, right? Let's take the rule at the top. What this rule says, rule number 1, let's go back to my example before. I had a test where I doubled scores. Good thing I'm a math teacher since I can't write or spell. I doubled scores and added 10. And let's say before we started, the standard deviation on my test scores was 10, which means the variance was 100. I'm interested in what the variance is after having gone through the exercise of doubling scores and adding 10. Well, what happened? Let's see. The new variance, okay, comes after I add 10 and double the original scores. And the symbolism up here would tell us, well, to get the new variance, we're going to take this doubling factor and square it. So I've got 2 squared times the original variance of 100. So the new variance after adding 10 and doubling is equal to 4 times 100, which is 400. That's my new variance. So it went from 100 to 400. What happened to the standard deviation? Well, if I want to get the new standard deviation, that's the square root of 400. So, and that we could compare to the original standard deviation, to 10. So to get to standard deviation, I have to get the variance first, using the formula, and then take the square root. Rule 2, let's go back to the bowling example here. Let's go back to the bowling example. It turns out that when I bowl, the standard deviation for my bowling scores is 3. When Spencer bowls, his is 4. The question is, what's the standard deviation for Spencer and Jeff together? So I'm interested in the standard deviation for us as a team. Well, it's not 7, because you can't add standard deviations. You can add variances. Okay. So the variance for Jeff and Spencer as a team is the sum of our variances. Well, my standard deviation was 3, so my variance is 9. Spencer's was 4, so his is 16. That adds to 25. So the variance for us as a team is 25. What's the standard deviation? It's the square root of that variance, which is 5. Not 3 plus 7. Not 3 plus 4 or 7, it's 5. So you can add variances and square root the sum to get the standard deviation, but you cannot add standard deviation. All right, let's work through an example or two here quickly. Here's one. We've got a game. The payoff of a $1 ticket is $500 with a probability of 0.001, and you win 0 the rest of the time. Find the mean, variance, and standard deviation, and we're just going to focus on winnings here. We'll ignore the dollar cost of the ticket. The mean, variance, and standard deviation. We're interested in the mean of this discrete random variable. Recall that it's equal to the sum of every outcome times its probability. So here the outcomes are $500 winning with a probability of 0.001, 0 winnings, probability of 0.99, and if you do that math, you get 50 cents. How about the variance? Well, recall that that's equal to the sum of every outcome minus the mean squared times the probability of that outcome. So our two outcomes here, $500 winnings minus a mean of 50 cents squared times the probability of that outcome. Added, because we add them together, the next outcome, 0 minus 50 cents squared times the probability, times the probability of that outcome, which is 0.999. If you do that math, you get $249. Actually, you get $249.75. So to get the square root, we're going to take, to get the standard deviation, we're going to take the square root of the variance. The variance was $249.75. The standard deviation is the square root of that, which is $15.80. Question says, what if you play twice but on different days? What's your expected payoff? Well, if I play twice, remember I can add means. So if I played twice on consecutive days, let's X be day 1 and Y be day 2, I can add means. I'd expect to win $1. What's the standard deviation for playing 2 days in a row? Well, I can't add standard deviations, but I can add variances. So playing 2 days in a row, the variance for playing 2 days in a row would be 249.75 plus 249.75, or 499.50. And the standard deviation for playing 2 days in a row, X is day 1, Y is day 2, is the square root of that. So again, a reminder, you can add variances, but you can't add standard deviations. So the standard deviation of this game, playing 2 days in a row, the combined winnings would be $22.35. All right, next question. College uses SAT scores as one criteria for admission. Experience has shown that the distributions of SAT scores are such that the math mean is 625 with a standard deviation of 90, the verbal mean is 590 with a standard deviation of 100. What are the mean and standard deviation for the total score? Well, again, you can add means. So the average total score should be the sum of the means, which is 1,215 points. What about standard deviation? Well, here you might be tempted to add variances, but keep in mind, you can only do that if the events are independent. There's a subtle rule there. And I'd argue that your SAT math and verbal aren't independent. That if I know something about your math score, I have a sense for what your verbal score might be. So, what's the variance? Well, at least in our capabilities right now, we can't calculate it because the events aren't independent of each other. Trick question. All right, there's one more example here I want to go through, but I'm going to run out of time. I have a minute left in this 15-minute window. So I'm going to stop this. Please watch this. Actually, this is going to be a useful problem to you. You're going to want to know how to execute this one. So make sure you watch the golf problem here, which will take about 5 minutes or so to go through.